So, in discussing eclipses, we said that an eclipse season occurs when you get a new moon or full moon close to the time of the year when everything lines up. So that the eclipse seasons occur about every 5 2/3 months. Okay, so it's just a little bit less than just like a week or a week and a half shy of every 6 months. And so if you get a new moon, the shadow of the moon would actually hit Earth. And so if the shadow of the moon hits Earth, if you happen to be in that spot, then you would actually experience a solar eclipse, a total solar eclipse. Now, let me point out a couple things in this diagram. This diagram is straight from your textbook here, okay, and shows the orientation of how the moon lines up. Okay, what happens is that as this and this is actually page 62 of your textbook. If you're exactly the right spot, all the sunlight is blocked by the moon and there's no light there. We call that the umbra. The umbra is this dark shadow caused by the moon blocking the sun's light. But there's a partial shadow that's here. So some of the sunlight goes past the moon, but some of the light is blocked by the moon. And so in that case, then if you were standing in a spot, like that, then what would happen is you would see the moon blotting out part of the sun. Well, since part of the sun's blotted out, it's less bright, but it's not black, like it would be with a total eclipse. We call that the penumbra. The penumbra is this lighter portion of the shadow. The lighter portion of the shadow where part of the sun is blocked. The umbra is where all the sun is blocked. Okay. And so what happens is the sunlight will shine past the moon, so the umbra makes this sort of cone-shaped shadow that stretches down to the earth. And it turns out it's a very narrow region across the earth where the sun is totally blocked. So a total solar eclipse is very, very narrow. The moon moves roughly its own width in an hour in the sky. So if you're standing on Earth watching, then what would happen is it would take an hour from the beginning of a partial eclipse or beginning of an eclipse until it's total. Well, the sky's turning. It turns about 15 degrees an hour. So you would see the beginning of a solar eclipse, and then as time passes, the sun's moving across the sky, getting more and more eclipsed until finally it's totally eclipsed, and then it starts coming out. Now, the moon is barely able to cover the sun, so it's only eclipsed for a very short period of time, sometimes just seconds, and sometimes just a couple minutes. If you ever watch a solar eclipse, and there will be one in Texas in just a few years, things happen very, very rapidly. So even if you think you're prepared to look and see all the stuff that's happening, the moon is blocking the sun. You see the sun's corona shining around it. It's starting to get dark. You start seeing the street lights come on. The birds start going to roost. Crickets start doing their thing. I mean, it's all of a sudden things are changing. You can look off in the distance and you can see the edge of the brightness, edge of the darkness, and so it's like bright off in the distance, even though you're in the shade. And then the temperature is changing because now the sun's blotted out and it's getting cooler. Clouds that were forming are collapsing because of the lack of solar heating. You get shadows starting to look weird, and then it's all over. And so while you're looking around at all the stuff, you're missing the eclipse. And so it's a very, very thrilling sort of thing. And I've been to a solar eclipse, and I knew exactly what to expect, and I still almost missed a lot of stuff, simply because it happens so fast. NASA puts forth these eclipse tracks because a lot of people want to go see the eclipse. And so when you put these eclipse bulletins out, then what the eclipse bulletins do is they mark where on Earth the path of the eclipse is total. And so if you happen to be in that little blue band there, you would get a total eclipse. Now, surrounding that is a region of partial eclipse. And they call the magnitude of the eclipse. Now, the magnitude of the eclipse is kind of interesting. A 0.5 magnitude means the moon covers half the edge of the moon covers half the sun. It does not mean half the sun's covered. Because if that is the sun, the moon would be there, and that is the part covered. Yes, it's halfway across, but because the moon's round, there's portions of the sun still shining around there, and so it is not exactly 50% covered, even though it's a 0.5 or 50% magnitude. This is often is something that happens, and when we do have an eclipse here in Texas, that's one of the things they're going to mess up next time it happens, is that you're going to hear on the news, hey, you're going to have like 80% of the moon covered. Well, it's not going to be 80%, it's going to be 80% magnitude, but because the moon is round, it's going to be closer to like 70-something% of the moon that's actually covered. So the other thing that the Eclipse Bulletin does for you is the Eclipse Bulletin marks when the various events happen. Because as the moon moves by, you don't see it all at the same time everywhere along that path. There's different times here. We call P1 the time when the partial eclipse begins. U1 is when the total eclipse begins. U4 is when the total eclipse ends. Don't worry about what happened to U2 and U3. That's beyond this class. Okay, and then P4 is when the partial eclipse ends. And again, don't worry about P2 and P3. Professional eclipse watchers worry about those times, but that's not something you're going to really want to worry about. So, there actually was a partial eclipse visible from the TCC campus a number of years ago, and we set up telescopes to watch the partial eclipse here on campus, and those are some photographs that we actually took of the eclipse. And on this bottom photograph right here, that's a tree right there, because the telescope actually turns all the images upside down, and so the tree started appearing at the top because the moon was actually setting while it was eclipsed. So the eclipse happened in the afternoon, and we never saw the entire eclipse beginning to end, because it started when the moon was getting low in the sky, and it ended while it was still partially eclipsed. Rather, the moon set while it was partially eclipsed. There's another one that I took in a solar eclipse. That's this most recent solar eclipse, and again, you see the moon starting to cover part of the sun. And that most recent solar eclipse was August 21st, about 3 years ago, in 2017. And it went right across the United States. Now, here in Texas, we had a pretty good 0.8 magnitude eclipse. 0.8 magnitude, again, does not mean 80% of the sun was covered. It just means that the edge of the moon went 80% across the sun, so it was really like 70-something% that was covered, but that was enough to blot out a bunch of sunlight, and it actually got cooler, and the birds started to roost. Now, I had actually traveled across country and was right in the center of the eclipse, in fact, right close to where the eclipse was maximum in the United States, which was up near the Tennessee-Kentucky border. And my wife was here, and she noticed that it was getting cooler, and the chickens started going to roost, and there were a variety of other sort of things that were happening here. So even if you don't get a total eclipse, there are a lot of things that you do notice are happening. Some pictures here of the total eclipse that I was at, and as it was starting to get total, and you could still see the blue sky off in the distance right there, but the street lights were coming on where we were, and you could actually see even edge of the chromosphere, the colored portion of the sun. Near total eclipse, and you can see parts of the corona. So that's what. So those would be the conditions for a total solar eclipse. Now, let's talk about, what would happen if you're not exactly in the center. So, for example, Texas was not right where the umbra was going, and so the penumbra, partial shadow, in other words, part of the sun was blocked out, so you get a partial solar eclipse. Well, there's another interesting thing that happens, and we'll talk about that in the next lecture slide.